Math 110, Polynomial Division, the Remainder Theorem, and Factor Theorem, Section 4.3. Now, finding the zeros of a polynomial isn't exactly going to be straightforward at times, and so factoring, we're going to have to employ other forms of tools that are going to be able to help us find, the zeros or the factors of a polynomial. So, for example, if we take this one here, I can't factor that. I mean, we have 4 terms, but I can't factor it using any of those other forms of factoring that we know, like the factor by grouping. If we try it here, it wouldn't factor. But this polynomial does factor into this statement. The factors are going to be x minus 3, x minus 1, and x plus 2, and the zeros are still going to be 3, 1, and negative 2. So there's eventually going to be this pattern that you're going to see develop over the next few lessons, and it's going to say, basically, when we know the polynomial, you're going to be able to figure out the zeros somehow. And we could also make that converse statement where if we know what the zeros are, we can figure out what our polynomial is. And you're going to realize that this is going to be a two-way street as we learn more and more tools. So one of the first tools that we need to know how to do is to be able to divide. Now we can check to see if it's going to be a 0 if it divides evenly. So that'll be the first thing we'll see. It says divide to determine whether x plus 1 and x minus 3 are factors of x cubed plus 2x squared minus 5x minus 6. So let's do it. If I divide x plus 1 into x cubed plus 2x squared minus 5x minus 6. Now to do this, what we want to do is we want to take the first term and divide it into the first term. So basically this statement here. Now if you simplify it, you're going to get x squared, and we're going to write that on top. Then you take the x squared and you multiply it through. So you're going to get x to the third power and x squared. Then you have to subtract, so we're going to change the signs, bring everything straight down, you get 0, you get x squared, and then now we need to bring over the next term, which is minus 5x. We repeat the process over again. So now I want to take this term and divide it into this one. So I'm going to get x squared over x. And so that just gives me plus x. Now I want to distribute that x through, so I'm going to get x squared plus x. Then I want to change the signs. And if I add straight down, I get 0 minus 6x, and then I bring down the negative 6. So now I factor x into minus 6x. They cancel out, and I get minus 6. Multiply it back through. And then I change the signs, and I get 0. So because my remainder is 0, I know that when I divided this, I know that this is going to be a 0. Okay? Or if I know it's a 0, I can also determine that it's going to be a factor. So I know that x minus 1 is a factor. Now let's check the next one. X minus 3. So same thing, we need to set it up. So x goes into x cubed, x squared times. And so distribute back through, you're going to get x cubed minus 3x squared. So subtract, so we're changing the signs. Add straight down. Bring down the next value. Repeat the process. So x goes into 5x squared, 5x times. Multiply it through. Change the signs. So I get 10x, bringing down the next value. X goes into 10x 10 times. Multiply it back through. Change the sign. And so that's going to cancel out, and I get plus 24. Now, because my remainder is positive 24, I know that x minus 3 is not a factor. which this is now going to lead us to the remainder theorem. Now, what this states is that if a number c is substituted in for x in your polynomial, like we're evaluating c, or evaluating for c, then the result, f of c, is the remainder that would be obtained by dividing. So dividing and evaluating, whatever that remainder is, it's basically going to be the same thing. And so that's to say, if f of x equals x minus c times, okay, my quotient plus r, then f of c is going to equal r. Okay, then f of c is going to equal r. So dividing and evaluating are going to be equal processes in finding that remainder. And we're going to see that being, we're going to show that in an example in our next one. Now, another type of division is going to be synthetic division. Now, we set this up a little different. What we do is we take the coefficients. There's no 0x here, so I have to remember that. But we take the coefficients and we just write them. 2, 7, 0, and negative 5. Then whatever the 0 is, you're going to put that in this box here. And then you're going to follow this process of adding straight down, multiplying these two numbers together, and putting it in the next space over. Once again, we're adding straight down, multiply these two values together, and we're going to put it in the next box over. Adding straight down, multiplying it together to put it in the next box over. And so this is now going to be my remainder. This is going to be my constant. This is going to be my x, and this is going to be my x squared. So I can say that after dividing it, I can say that I have 2x squared plus x minus 3 plus 4 over x plus 3. That's going to be my division. But the important thing here, referring to our remainder theorem, is that remainder is 4. So that means, what if I take that 0, negative 3, which is my c, and I plug that in? So you're going to get 2 times negative 27 plus 7 times 9, and that's going to be minus 5. And so that's going to be plus 63, and that's going to be negative 54. And so negative 54 plus 63 is going to give me a positive 9. 9 minus 5 is going to give me 4. And so those two values are the same thing. And so that kind of verifies the remainder theorem there. Let's look at another one. So using the remainder theorem, let's find what the remainder is going to see. If the remainder is 0, we know that it's going to be a 0. And so I could actually just evaluate for this to see if this is going to be a 0 or not. So let's determine if 5 is going to be a 0 of this polynomial. You'd plug in 5 into our formula. 5 to the 4th minus 3 times 5 squared plus 4 times 5 minus 1. And so now this is going to be 625 minus 3 times 25 plus 20 minus 1. 625 minus 75 plus 20 minus 1. As you can see, like, just looking at this is not going to be 0. So 5 is not a 0. Okay, and so I use the remainder theorem to just be able to verify that. Now you could also do synthetic division or some sort of division to be able to do that. Now, why did I do those two different divisions? You're going to find out that synthetic division is actually going to be a lot easier. Okay, so going back to the synthetic division, you're going to find that the synthetic division is going to be a lot easier. As you saw, this was a lot quicker for me to just be able to do and simplify everything down there. Well, so synthetic division is going to be easier, but synthetic division has a limitation, and that limitation is what I'm dividing by. I can only divide by when it says like x minus c. Okay? When it's in the form of like this factor where it's x minus c, that's when I can divide it. If it said divide by x squared plus 7, then I can't do synthetic division because the highest power here is 2. So that basically, that's one of the ways, remember, looking at it. If it says x to the first power plus or minus something, then you can use synthetic division. But just know that if it's like a 2 or 3 or 4 or 5 as the highest power, you won't be able to use synthetic division. So example number 4 says determine whether I is a 0 of f of x. So determining if it's a 0, you can do two things. You could either plug I in or use synthetic division or some sort of division. I like synthetic division, so let's practice doing that. So I is going to go in the box since that's my 0. I'm going to write my coefficients, which is going to be 1, -3, 1, and -3. Bring down the 1, multiply. So 1 times I is I. Now I'm going to add, so I'm going to get -3 plus I. Now I'm going to multiply that through again, but I'm going to do that off to the side because just make things a little more visual. So you get -3i plus I squared, which is going to be -3i minus 1. So I get -3i minus 1. Now add. Now when you add, the positive 1 and the negative 1 are going to cancel out, and so you're going to be left with -3i. Now multiplying again, -3i times I, you get -3i squared, which is -3 times -1, which is positive 3. Add straight down, and I got 0, so therefore I is a 0. Now the factor theorem says for a polynomial f of x, if f of c equals 0, then x minus c is a factor of it. So if you plug it in, whatever you're evaluating, then you can write it as a factor of x minus c, which is kind of cool, and you kind of see things go full circle, that if it's a 0, you know it's also a factor, and I can use that as part of my tool to break it down. But to be able to factor it down, you're going to be using synthetic division or long division to do so. So in this example here, it says let f of x equals x cubed minus 3x squared minus 6x plus 8. Factor f of x and solve the equation f of x equals 0. So it wants me to factor this, and right now I don't have that magic tool that just says, yep, I can just start breaking this down. We're going to learn that in the next lesson, and that's going to be the rational roots theorem. But right now we can just start trying numbers, so let's try -1. And so if I try -1, writing my coefficients, bring down the 1, multiply, add, multiply, add, multiply. Okay, 10. Nope. So -1 doesn't work. Let's try a positive 1. Bring down the 1, multiply, add, multiply, add, multiply, add. So it works. It was able to break down. So therefore, I know that this is my constant, this is my x, this is my x squared. So since I know that that is my 0, it's always going to be x minus your 0. And I can break it down that way. So I'm going to get x minus 1. And then I have my 1x squared minus 2x minus 8. Now that statement there, I can factor that further. That's going to factor into x minus 4 and x plus 2. And so here I have fully factored the equation. So the other thing, it says and solve the equation. So that means I have to know what my zeros are, and so my zeros are going to be 1, 4, and -2. So this is the answer. If you guys have any other questions, please let me know.